Okay, in this lesson we're going to look at integration by parts, where you need to repeat the process. And this is where it gets fun. All right, so integration by parts may lead to another integral that you'll need to integrate again. And then eventually it's going to enter these things called recurrence relations, which we'll talk about later. In order to solve this, we just need to apply the process until the original expression is reached. So let's have a look at a simple example first. So this one's just going to reply repeated applications. So let's start, actually let's get rid of those, we don't have time for that. We're going to go u equals x squared, v dash equals e to the minus x, okay, because we usually let v dash equal the integral. Differentiate, integrate. Apply the process, so it's uv minus the integral of u dash v. So those two minuses can cancel. 2x e to the minus x with respect to x. Now obviously we can't integrate that. So we're going to go again with this one. So we're going to get u equal 2x, v dash equal e to the minus x again. Now you need to be very careful if this minus hasn't cancelled out. That's a flag there for you. U dash equals 2, v equals negative e to the negative x. And now we'll go again. So we'll write this one out. Good news, it's a plus. If it's a minus, I suggest you sort of do a bracket here. So how do we go? uv, so this will become plus negative 2x. I'll worry about that in a moment. Minus the integral of that, so that, with respect to x, and now I can easily integrate that. So that becomes negative 2 e to the negative x plus c. So here's a similar one, which you can try yourself, and that's a sample question. This one here is your challenge. And we'll discuss both of those during our lesson. Okay, so what happens when the repeated application doesn't work? It's going to send us on a little loop. So we'll look at an example of that next. So when we think of this one, you know, whenever I start differentiating or integrating e, it's not going to break down. It's going to stay at e. And when I do with sine, it's the same thing. It's not going to break down like x squared broke down to 2x and then 2x broke down to 2. Sine x is just going to alternate between cos and sine. So let's imagine we hadn't spotted that first and we're saying, okay, I want to integrate e to the x sine x with respect to x. Okay, and it actually won't matter which one you let u and v equal. I think I'll go with our standard where we'll go u equals sine x, b dash equals e to the x, because we usually grab the exponential. So v will equal e to the x. U dash will equal cos x. So when we do that, we will get e to the x sine x minus e to the x cos x, which is not looking very helpful, is it? So I'm going to go again. We're hoping it's going to be helpful. Repeat the process. Make sure u remains with the trig function. Don't try and change it now, thinking life's going to be easier. So now u dash will equal negative sine x and v will equal e to the x. And I'm going to have to be careful because of this negative didn't cancel out this time. So I've got e to the x sine x minus, okay, so I've got uv, so e to the x cos x minus, and that minus will cancel, so plus e to the x sine x. Okay, so let's just neaten that up. Minus, what have you noticed has happened? Well, we've got back to the original question. The original question asked us to find this integral. And I've just got back to some extra stuff. We haven't wasted our time, don't worry. At this stage, let's just call this integral I. Quite often it's called IN, but I'll come back to that in a moment. So I equals this, but this is I as well. So if I brought that over, let me just rewrite that as the integral. That just saves me writing that out again. You can write it out again if you prefer. Bring the I over, so we have 2I and that would mean that the integral, which I'm trying to find, is a half of that, half e to the x. Maybe I'll take e to the x out as a common factor. Sine x minus cos x. Just make sure you put your plus c on at the end. You don't need to put it in here because it is an integral, so it could already include the plus c, but just make sure that goes on your final step. So this is one when you start integration by parts, you get back to where you started from, which will be pretty obvious if it's e and some sort of trig function like that. So if you recognise it straight off, let I equal the integral. Integrate by parts. As I said, it won't matter which one you choose here. You could use e to the x here and sine x here, but just keep that pattern. So after I integrate by parts, I repeat the process. So since I chose v dash as e to the x, do that again. Don't mix it up. Go again. Now I've got the original integral. Pop it over the other side. Two of the integrals make this. So one of the integral is a half of that.